Okay, so we're going to continue with our law of sines, and this is the next part, which is still in section 5.5. We're going to talk about the ambiguous case, the SSA, and this is the case where you have to do multiple calculations. So the way I like to remember it is SSA kind of spells backward is the but, so it's a pain in the butt question. So that's how I like to remember it. Okay, we're still looking at PC.G.5. That's what we're focused on. Okay, so we call this the SSA, the ambiguous case. So you might end up with no triangle, one triangle, or two triangles. Okay, so what I mean by that is you might end up for any of these situations that matches with the given situation, the given scenarios. Like for triangles like this, you might have one triangle that satisfies this, or you have two triangles, you have no triangle that satisfies that basic requirement. Okay, so before we go through this example, let's go through some of the steps that you need to go through. So step number one, draw and label a triangle. Okay, so in this and the relationship. Okay, the relationship is the putting all the sine, angles, and the sides together. Okay, so the next thing you should do, okay, I'm going to use A as my general focusing angle of interest that's given to you. Given angle A and side A. Okay, so step number two, solve for one of the unknown angles. In that case, follow kind of like what we did yesterday. Step number two, okay, you might end up with just B. Okay, so there might be, you might have to figure out if there's only be no triangle or one triangle. Okay, if you don't have a triangle in step number two, the answer will stop. You can't find anything after that. And that means you end up with no triangles. Okay, in a little bit we'll go through a little example. Okay, and then if you are able to solve for it, in this case using B as an example, that will give you the first angle. Okay, so in that case, I would label it as B1. Okay, if you find that it works, the next thing you should do is 180 degrees minus what you found for B1. Okay, if you come up with an answer, good. We're going to use that number to figure out if the second triangle is possible. So in that case, in step number 4, you use the angle you given A plus angle you found in B, add them together. If the number is less than 180 degrees, if the number is less than 180, that means you have two triangles. Okay? If the sum of it end up greater than 180, A plus B2 is greater than 180, that means you only have just one triangle because the other triangle will not exist. Okay? So given these two scenarios, if you have one triangle, you solve for the other C and side C. Okay? If you have two triangles, you have to find two pairs of angle C and two pairs of side C. Okay? So in that case, again, just follow the procedure and figure it out. Okay, number 6, state your solutions. Okay, it's very important that you state your solutions. Make sure you write it in a systematic order so you don't mess yourself up. And I like to label my angles. Like if it's triangle 1, I like to label as 1, and triangle 2, all my angles and sides will be with the subscript of 2. Okay, so let's go ahead and go through this example. This is on page 492 in your textbook. This is, in this scenario, you end up with just one triangle. Okay, the given situation is that side A is 7, side B is 6, and angle A is 26.3 degrees. So, step number 1, draw your triangle, and then state your relationship. That means sine of 26.3 divided by 7 is equal to sine of B. We don't know what angle B is, but we know the side B is equal to 6. And we don't know anything about C. Okay, angle C or side C. So in that situation, let's move on to step number 2, which is solve for one of the unknowns. In this case, let's go and solve for what B is. So solving for B, moving the 6 up, and you end up with sine of B is equal to 6 sine of 26.3 over 7. Okay? Got to make sure you put in your angles. You don't want to mess yourself up. Okay? So with that in mind, to solve for what B is, you do arc sine of B of the number you have over here. In this case, you put in a calculator, you end up with 22.320 degrees. Okay, that means in this situation, we end up B is equal to 22.32 degrees. Okay, like I mentioned, in this over here, the first angle you find labeled as 1. Okay, so angle B1 is equal to 22.320. Okay, now the next part here, you got to figure out what B2 is. Okay, in that case, B2 is equal to 180 minus B1. So 180 minus B1 is 180 minus 22.320. Okay, So you put it in your calculator, you end up with 157.680. Okay, that's angle for B2. Okay, now we move to step number 4. You add angle A, the one that you have here, with angle B, B2. Okay, if your angle is greater than 180, you end up with no triangle in that situation. If you add up and an angle is less than 180, you will end up with 2 triangles. So in that case, A plus B2, so 26.3 plus 157.680. If you do the sum, it's greater than 180 degrees. In this case, you end up with just one triangle, because in this case, if the sum of two angles exceeds 180 degrees, that means you end up with no triangle. But this situation, because the interior sum of the interior angles of a triangle is 180 degrees. In that case, end up with just one triangle. The one triangle is, in this case, the B1 situation. So all we have to do now is figure out what is B1. Use B1 to solve for what angle C1 and side C is equal to. So in step number 5, in this case, you solve for the one triangle we have. So C is equal to 180 minus A minus B1. Okay, we know what A and B are. So in 180 minus those 2, we end up with 131.380 degrees. So that means my angle here for C is equal to 131.380. And all we have to find now is the remaining side. Okay, the remaining side here, just setting up our triangle, our law of sines. So we know this one, we know C as well. So in that case, we use the relationship between A and C. Okay, so we end up with sine 131.380 divided by C is equal to sine of 26.3 divided by 7. By rearranging, move the C up, move 7 up, and sine of 26.3 down. C comes out as 11.855. That's a distance, that's a length. So in step number 6, state your solutions. In this case, when you have one triangle. So in that case, B is equal to 22.320 degrees, C is equal to 131.38 degrees, and then my side C is equal to 11.855. Okay, so in that case, we're looking for these 3 things, and we have these 3 things. In that case, we're good to go. So in that case, example 2 is completed. Okay, so far so good? Okay, so let's move on to the next part, which is example number 2. This is also in your textbook. It's on page 429. In this situation, you end up with 2 triangles. Okay, so we're given a situation A is equal to 6, B is equal to 7, and angle A is equal to 30. So step number 1, draw your triangle and state the relationship. In that case, draw my triangle, make sure it's correct. The angle and sides must be right across. In that case, we're looking for angle C, side C, and angle B. Okay, keep that in mind, all right? So just find we have the relationship of sine of 30 divided by 6 equal to sine of B divided by 7 and sine of C over side C. Okay, so step number 3, or step number 2 is to go ahead and find what B is equal to. In this case, sine of B is equal to 7 times sine of 30 divided by 6 just by rearranging this equation. And then to solve for what B is, we have to undo the sign. So we do arc sine here. Arc sine of this number here gives me 35.685 degrees. Okay? That means B1 is equal to 35.685 degrees. So in that case, we're going to find the other angle that might be complementary to it. In that case, end up with is 180 minus B1 gives us 144.315 degrees. Okay, so B1 is 35.685 and B2 is equal to 144.315. So in that case, B1 is triangle number 1 and B2 is my triangle number 2. Okay, let's go ahead and test it out. So A plus B2, if you do the sum of these 2 numbers, so in that case using what's given, A is 30, B2 is 144.315. If you add those together, you get a number that's less than 180 degrees. In that case, because it's less than 180 degrees, you will have 2 triangles. Okay? So in that case, since we have 2 triangles, let's label them as triangle 1, which is subscript 1, and triangle 2 is subscript 2. So in that case, you have to find 2 sets of C and 2 sets of side C, and that's what you have to do after this step. Okay, so triangle number 1, we use the one with 35.685 degrees as my B value and solve for what C1 and C1 side is equal to. So C1 in this situation is 180 minus A minus B1 gives me 114.315 degrees. That means my C1 is equal to 114.315 degrees. Now, what we have to go find now is what C1 is equal to. So we're going to use this number here, and so in that case, we're using this relationship with this thing. So sine of 30 over 6 is equal to sine of 114.315 divided by C. Okay, in this case, C, just by rearranging this equation, move the C up, move the 6 up, and then move the sine of 30 down, you end up with 10.936. Okay, that's my side for C1. Okay, in that case, we found the C1 for the angle and the side for this triangle. So that means this triangle is completed. Now, we got to move on to the second triangle. Okay, we have to use B2 in this situation. That means sine of 30 divided by 6 is equal to, again, using these two relationships because that's what we need to figure out, sine of 144.35 degrees divided by, in this case, 7. Okay, so that's B2. Okay, so in that case, 180 minus A minus B2 gives us 5.685 degrees. That means my C2 angle is equal to 5.685 degrees. Now, all we have to find now is what C2 is equal to. So C2 in this situation is going to be, we're going to use this relationship. Okay, so C2 is equal to, well, C2, just by rearranging, end up with sine of 5.685 degrees. Move this up, switch across, end up with C2 is equal to 1.189, and that's my distance. Okay, next thing. So in this case, we end up with triangle number 1 and triangle number 2. So in triangle number 1, what we have to put in is my B1 and C1, in this case we found here, and then my sides B1 and C1. Okay, so the B1 here just to match it up. Okay, so B1 never changed. B2 never changed for this side. So it's triangle number 2, we end up with the numbers, we just put them together. So the reason why we do that is when we have this all together, it's very clear what type of triangles we have. Okay, so you end up with the 2 triangles. Okay, so that is the end for example number 2. Last but not least, example number 3. This one is not in your textbook, so I wrote it up from a different book, but it demonstrates with the situations where you have no triangles. Okay, we're given the situation A is equal to 2, B is equal to 1, and angle C is equal to 50. Notice how the order changes. In that case, it's no longer A, B, and C. It's just A and C. Okay, so first step, draw up the triangle and state the relationship. In this case, the first thing we want to solve for is angle A. Okay, because that's the angle that we know, that we don't know, but we're given a side about with information about the side. That means sine of A is equal to 2 sine of 50, because moving the 2 up, move the 1 up, and keep the 1 here. So in that case, sine of A is equal to 2 times sine of 50 divided by 1. Okay, so if you put it into your calculator, 2 sine of 50 over 1 is 1.532. But because the range for sine is between -1 and 1, therefore, because 1.532 does not fall within within the range, that means you cannot solve for this number. Therefore, in this case, the triangle does not exist. Okay, I will post a couple more examples. I'll probably just post it and just look through them. If you have questions, let me know. Otherwise, just work on the assignment that I've assigned you. Okay, make sure you ask questions. I'm here to help. So that's all for today. Okay, see ya.